My dear friends, now we are going to look at decimal adder, module 4, lecture 51. So what we try to do is we will look at decimal adder. We have seen already what is decimal addition. So in this process we would be looking at a circuit which is capable of uh, doing decimal addition. As I told you, we would like to add 0 to 9, a decimal number, any number of BCD. What is BCD? Binary coded decimal. Binary coded decimal means all 0 to 9 are binary coded. Binary coded is 0 0 0 0. 9 is 1 0 0 0 1. Right? So 1 is, what is 1? 1 is 0 0 0 1. Similarly 2 is 0 0 1 0. So on and so forth up to 9. But after 9, no more decimal numbers. Decimal numbers are from 0 to 9 only. But with 4 binary digits, 0 0 0 0, I will get 1 1 1 1 1. Total 16 possible combinations. Out of that, we are using only 9 combinations. So when we use this 9 combinations and if we add the number, okay, that may fall into a number which is greater than 9. For example, 1010 is the next. 1001 is 9, 9. This is A. 1011 B up to F. So A to F are not there in our BCD. But if I add a 9 to 1, for example, 9 plus 1 is 10. 10 BCD representation is 1 followed by 4 zeros. BCD representation. But the same thing in binary, if at all you look at it will be 1010. This is not the correct way because why it is not the correct way? I want BCD. So as I have explained already, if you want to correct the result, add 6 to what? Any result which is greater than 9. To correct it, okay, you will get a proper value. How? Let's look at it. Let's say 9 plus 1 is 10. If I add 6, what it will be? It will be 16. Okay, what is 16? 16 is nothing but 1 0 in the binary number system. So what we are trying to do is, by adding 6, we are coming back to BCD. So the deviation between BCD to 4-digit binary is only 6 digits variation. These 6 digits. These 6 digits. Okay. Since we are using 4 digits of binary, it is giving you 16 possible combinations. Hence, we are calling it as hexadecimal. So, hexadecimal is not a different thing. It is a 4-bit binary actually. 4-bit binary results in hexadecimal. So, hexadecimal is fully binary, 4-bit binary. Once you understand this, then it's simple. If sum is below 9, there are no issues. If sum is above 9, we need to correct it. That is what exactly I am teaching. Then to correct the result, we need to add 6. Okay. So this process we are trying to see. When we are adding the binary sum, when we add the numbers, so we will get the sum here is represented. What is the maximum sum? 16 plus 3, totally 19. This is what exactly maximum sum. So any sum which is less than 9, this region, no issues. Any sum, what is that BCD sum? If it is greater than 10, greater than 10 means what exactly that is happening is, see here 1010, 1011, 1100, 1101, 110, 111. For this, the correct representation is 10 in BCD. It is 10, 10. So 1 followed by 0. 1 followed by 1, 1 followed by 2, 1 followed by 3, 1 followed by 4, 1 followed by 5 is 15. Okay. But when we add the numbers, what exactly? The maximum number addition is 9 plus 9 plus 1. Why? 1 carry in, let's suppose. So 9 plus 1 is 10 plus totally 19. So the maximum value is 19. Okay. So up to here is 15. Next it is 16, 17, 18, 19. 19 representation in binary. So what is 19 representation in binary? Binary is 16. This is 16. 16 plus 1, 17. 16 plus 2, 18. This 1 is 16. So plus 3, 19. Right? Is that fine? So next what I try to do is, see here. This is BCD sum that we are looking for. But this is what exactly the binary sum. So I need to do some correction, something I need to do to this binary addition such that the result will be in BCD. In simple words, what we are supposed to say is, the result what we are adding will be 0 to 9, A to F. Okay. Then followed by further numbers. So what we try to do is, this A to F I need to remove. To do that, when the result is greater than 9, we will add 6 to A. It will become 1, 0. Okay. So likewise, if the sum is greater than 9, we will add 6. Once we add 6, then everything will be in BCD form. Okay. So for that, what we try to do is, we will look at this. When we need to add 6, if at all we can decide that, then the problem is done. When we need to add 6 to the result. Say for example, if anything is greater than 9, I need to add 6. That we know in statement. But in expression, if at all you look at, whenever there is a carry, what is mean by carry? When the result of the sum is greater than 4 bits, or if this Z8, what is that? Is it not 8421 code? Yes, it is 8421 code. It can be anything ABCD, but here it represented as a Z8, Z4, Z2 and Z1. So weightage of this is 8, weightage of this is 4, this is 2. 8421 code, okay, which we know already. So what I can say is, when carry is 1, or when Z8 is equals to 1 and Z4 is equal to 1. 8 plus 4 means how much? 12, which is greater than 9. So when Z4 and Z2, or is it Z4 and Z2? No. See here, Z8 and Z2. Z4 and 2 will give only 6. Z8 and Z2. Z8 and Z4. So for the case of whenever Z8 is 1 and Z2 is 1, whenever Z8 is 1 and Z4 is 1, the result will be greater than 10. 8 plus 2, 10. Okay. So similarly, when Z8 is 1 and Z4 is 1, for sure the result is greater than, okay, for sure the result is greater than 10, 12, right? Because I am talking about only Z8 and Z2. If both are 1, the sum is 10. If Z1 is also 1, let's suppose, it becomes 11. Okay. Similarly, Z4 is 1. So likewise, what I can say is, with respect to the logic, when this is, when K is 1, what is this K? There is a carry. When there is a carry, okay. So what I can do now is, just let me take a different color. When K is 1 and when Z8 is 1, or when Z8 is 1 and Z2 is 1, Z8 is 1 and Z4 is 1 cases ensures that the result is greater than 9. So in those such cases, I need to add a correction factor by plus 6, so that I get my result in So this is what exactly that we are trying to do in the circuit. Look at the circuit. Now what we are trying to, when Ki is equal to 1 or when Z8 and Z4 is 1, that means the result is 12 and more than 12. This 2 itself is 12. If this is 1 and next one is also 1 or both are 0, also no problem. If these two are 1, which ensures that result is greater than 9. Or when Z8 and Z2, if they are 1, Z8 is 1, Z2 is 1, result is 10. So when Z4 is 1 or Z8 is 1, result is greater than 10, which is 12. Or if the result is when we add two numbers, okay, add and adjoint. When we add two numbers, one number to other number, if there is a carry, that is what is the meaning of that? The result is not fitting into 4 bits. Result is 5 bits. Okay. I am adding 4 bits to 4 bits. If result is 5 bits, means the number is greater than 9. Or if the MSB is 1 and next MSB is also 1, then result is greater than 10. Or if Z8, Z2 is 1, greater than is 10. So in such case, what we are trying is, we are using a adder, we are getting the result, then we are adding 6. This is 0, this is 0, this is 1, 1. If output is 1, due to anything it is 1, means what is the meaning of this? When this is 1, if any one of them is 1, this is 1. So what I am doing is this, we are applying it here as an input 0, 1, 1, 0, which values is 6. So we are adding 6 to the sum. So this is binary sum. To the binary sum, what we are doing is we are adding 6. When we add binary sum with plus 6, then we will get BCD sum. This is what exactly one has to understand. The condition for 6 to add, one has to understand. Then what we are using is binary adder. So when we use binary adder, I will get a binary sum. But I am not interested in binary sum. I am interested in BCD sum. So to get the BCD sum, what we need to do is binary sum plus 6 that I need to do. But how do I know when I have to add 6? That is what exactly the condition that we have discussed so far. The condition to add 6 is if the result of summation of binary numbers of 4 bits, if they result in 5-bit result, that means if there is a carry generated, or if MSB is 1, that is Z8 is 1, or and Z4 is 1. Z8 is 1 and Z4 is 1. Z8 is 1 and Z2 is 1. These are the cases for which the result is greater than 10, for which we need to add 6. So then we are going to get the BCD sum. Okay. So for example, if this is 9 and if this is 1, what I am going to get is 1 0 1 0. Okay, 9 plus 1, 1 0 1 0. Right. Now Z8 is equal to 1, Z2 is equal to 1. So what is this AND operation? 1. Okay. Is K generated? No, K is 0. Is Z8 Z4 1? No, it is 0. So 1 plus 0 plus 0, result is 1. This 1 will come over as a 6. This will be added to 1 0 1 0. 1 0 1 0 plus 6. 1 0 1 0 plus 6. What is that? 0 1 1 0. 0 plus 0 0. 1 plus 1 is 0. 1 plus 1 is 0. 1 plus 1 is 0. So it is 1 0. 1 4 zeros 0. So 9 plus 1 is 10. So I got 1 followed by 4 zeros. Okay. So where is that 1 coming? So from here, the carry out from this will be 1 coming. And here I am going to get 0 0 0 0. So carry 1 4 zeros, which is 10. So this is how it works. This is for single digit. If you want the 2 digits, so carry out of this, you give it to carry in of next stage. That's all. So this is for single digit. This is for another digit. This is for 2 digits. So 2-digit BCD adder. Okay. Or I can say 8-bit BCD adder. What is 1 digit? Adding 4 bits to 4 bits. Now here we are adding one more 4 bits to 4 bits. So totally 8 bits BCD adder. Okay, or if with respect to digits, if I talk, this is 1 digit adder, this is another 1 digit adder, totally 2 digit adder. Okay, next what I can do, I can go for 6 digit. What is that? Carry out from this will be carry in, carry out from this will be carry in, carry out from this will be carry in, then carry out from this will be carry in. Okay, carry out from this will be the carry. So this will give you 6 digit adder. That's all.